Hi, we're the Ocean-Going Robots ECE Capstone Design team. We consist of Malachi Fisher, Grayson Lewis, Miles Drake, and Samuel Barton. Our project is to develop a system to measure wave swell amplitude, direction, and period for the Slocum glider as it floats on the surface of the ocean while consuming a minimal amount of power. Goals we accomplished from last week include creating a rough block diagram for our system. We purchased and procured several STM32 chips and evaluation boards. We refined the requirements and risks in preparation for our final project document sections 1 and 2 draft submission. And we selected and procured a buck converter chip.
So the progress that we made in the block diagram is primarily in the black box diagram. We have a first rough draft completed, which primarily takes into account the environmental inputs, including swell height, period, and direction, as well as some of the data outputs that we'll be handling towards the end of our project, including the completion signals, raw swell data, and some process swell data that'll be sent over a telecommunications link. We also started designating and establishing some necessary blocks for the block diagram, but there may be some personnel changes as the project goes along. Component purchasing, we purchased 3 STM32 Nucleo boards. We received them all in the mail and we've started familiarizing ourselves with them. We've ran some test functions and stuff like that to see how they work and get familiar with the IDEs that we're going to be using. The project partner is going to be providing us with the XSense MTI3 development boards, as well as the chips themselves. But we're still looking for more STM32 microcontrollers and accelerometers that are not on a development board. But if we can't find any, we can still salvage some from the development boards we do have.
This past week, we worked to familiarize ourselves with the STM32 development environment. I wrote a Blinky program to verify that we had successfully programmed the board. Learned how to use the STM32 Cube IDE to configure the GPIO pins, which has a different system than I was used to from the Arduino development environment. We learned where to find the documentation for the STM32 HAL, or Hardware Abstraction Layer API. And since power consumption needs to be so low for this project, we're working on learning how to use the power estimation tool built into the Cube IDE to minimize the power consumption of our firmware. For the project document, we reviewed the feedback that we've received and we're making changes to get sections 1 and 2 ready for final submission. We're reworking our gap analysis since we received a lot of feedback that there were some other areas that we needed to consider. We're updating our timeline so that it's more readable. Some of the feedback we got said that the text was too small and that made it hard to read. We're also reviewing and updating our project risks, and we're going to update the requirements section with new formatting to improve readability.
For the power supply, we decided on the TPS 54232 buck converter chip. For our supply voltage from the collider, the main board is going to give us between 7 and 17 volts, and that TPS 54232 can take between 3.5 and 28 volts input voltage. So that works out fine. And the chip can also supply a lot more than our maximum current draw for our board. This chip being in stock at the TechBot store makes it a really attractive option with the global chip shortage. And we're still looking at possibly getting a different chip if we can find something that has more efficiency or lower current at sleep modes, but this is a good decision for now. And our goals for next week, we want to look more into the SD card data transfer and see if we want to do how many writes we want to do to the SD card. And we're also going to look more into the STM32 development boards, getting more familiar with the programming environment and investigate interfacing that with the micro SD card board. And we're also going to look more into the micro SD card power consumption and how that'll change during the write and read sequences.